All right, guys, welcome to Complex Conjugates. If you can get your homework out that you have already submitted, I want to show you the answers so you can see if you did them right. If you have not submitted it yet, don't think having the answers means you're going to get full credit for your late assignment. You will still only get a 50, and you must make sure that you show all of your work to even get any credit at all. So, to have your assignment out, go ahead and push pause and get your worksheet out and get ready to check your answers. Okay, so check your answers with what I have up here. If you have any questions about any of these particular ones, you can send me a message and we can work through them together. But this is what you should have gotten from that last assignment. All right, we're going to move forward. You have a warm-up on your notes. Please go ahead and pause the video. I want you to complete 1, 2, and 3. Number 1, you will multiply those two complex numbers together. Number 2, you're going to create an equation. That's a sum. And number 3, you're going to create an equation with a difference. So go ahead and pause this. Go ahead and work on your warm-up, and then press play when you're ready to check your answers. All right, so number 1, when you multiply your complex numbers together, remember we do the distribution method of FOIL, multiply the first pieces, the outside pieces, inside, and then last. So we get 35 plus 7i minus 10i minus 2i squared. Remember, I squared is the same thing as negative 1, so to say negative 2i squared is the same thing as saying negative 2 times negative 1, which equals 2. So we can simplify the next piece to be 35 plus 7i minus 10i equals 2. I added my real numbers together to get 37, and then I combined my imaginary pieces together to get negative 3i. So our answer for number 1 to be 37 minus 3i. Number 2, you got to create an equation where the sum of two complex numbers was going to be equal to 6 minus 2i. There's lots of options. Keyword here is sum, so they had to add it together, so it could be anything. I'm going to do 4 and 2 for my real numbers, and then I'm going to do, let's say negative 5i plus a positive 3i. That would give me negative 2i. So your answer might be different from mine, and that's okay. Number 3 wants you to create a difference. This is a subtraction problem, and they're going to have to equal negative 4 plus 8i. So to get negative 4, I'm going to do 2 minus 6. That gives me negative 4. And then to get positive 8, I'm going to, I'm going to add 2i to this. And then I'm going to subtract negative 10i, because if I subtract negative 10, that's the same thing as adding. Oops, I'm going to change this to a negative. There we go. Negative 2 minus negative 10 is negative 2 plus 10, which gives me that positive 8. There we go. So make sure yours work out just the same way I just did. And we're going to move on to complex conjugates. Here we go. So we did add, subtract, and multiply last time. So complex conjugates is our next operation, which is going to involve dividing. Okay. We cannot use a complex conjugate, though, until we know what it is. So a complex conjugate is a pair of complex numbers. Both have the same real part, but with the imaginary part having opposite signs. So an example would be 3 plus 4i and 3 minus 4i. Those are complex conjugates. They both have a real number of 3, but they're imaginary pieces. One of them has a positive 4i, the other has a negative 4i. So that's what makes it a complex conjugate. All right, so let's find the complex conjugates for these. So 7 minus 5i. The real part is the 7, so that stays the same. But the imaginary piece is negative 5i, so I'm going to flip the sign to make it positive 5i. And that's it. Number 2, keep the real part, which in this case is 12. My imaginary piece is positive 3i, so I'm going to flip my sign and make it negative 3i. I want you to pause and try to do 3 and 4. Pause the video. All right, so number 3, your real part is negative 2, so it's going to stay negative 2. Your sign does not flip. Your imaginary, though, was negative I, so now it's going to be positive I. Number 4, your real piece here is technically 0. This is technically 0 plus I. So to keep my real piece the same, I still have 0. You can write it or don't write it. It's up to you. But I, the opposite of that, is going to be negative I. So you could have just negative I, or you could have 0 minus I. They're both the same thing. Okay, now that we know what it is, why is it important? How are we going to use it? Okay, so we have to know the complex conjugate to be able to simplify the quotient of a complex number. Okay, let's think. What is the value of I? Do you remember? I equals the square root of negative 1. And what is restricted when we use the value of I? If we think back on our last notes, there were some rules. One of them was we could not have an I in my denominator. Makes sense, right? Because if I have an I in the denominator, that means I have a square root in my denominator, which is also against the rules. Okay, so we cannot have an I in the denominator. Because that would mean we have radicals in our denominator, which you should already know is not allowed. Okay, so this is when we're going to use the complex conjugate to get rid of the i's. I'm going to show you how that's going to work. Okay, so 1 and 2, you've done this before. You have rationalized the denominator when it was a square root. So to get rid of the square root, what you did was you had to multiply your entire fraction by that denominator, so you could eliminate your radical symbol, because the square root of 5 times the square root of 5 gives you just 5, right? And then our top becomes the square root of 40. We can actually simplify that to be what? 4 and 10. Square root of 4 is 2. So this actually simplified to be 2 square root 10 over 5. Okay, the whole reasoning was because we couldn't have the square root of 5 in our denominator. Same thing with number 2. There's a 3 under a radical in my denominator. I couldn't do it. So what did you do? You multiplied both pieces by the square root of 3. Because when you multiply a radical to itself, the radical goes away. So we have just 3 in my denominator. Our numerator this time became what? 4 times the square root of 18. 18 can be split into 9 and 2. The square root of 9 is 3. Those 3's can cancel out. This actually simplifies to 4 square root 2. So I kind of rushed through number 1 and 2 because you've done that before, so I don't want to waste any more time on it. The whole point for 1 and 2 is to remind you why we did what we did. We had to rationalize the denominator to eliminate the radical that was there. Okay, so we're going to use that same concept today with our i's, because to have an I down there means I have a radical and I got to get rid of it. Okay, so how are we going to eliminate? How are we going to get rid of the i's? We use the conjugate. Remember, the conjugate means you keep the real the same, but you change the imaginary piece. So with number 3, my complex number right now is 3i. The conjugate of that is going to keep the real number, which is technically 0, but the opposite imaginary, which is going to be negative 3i. And we're going to multiply that to both pieces. Okay, why does this work? Well, let's see here. 3 times negative 3 gives me negative 9. I times I gives me I squared. My numerator gives me 21i. You're thinking there's still an I down there, that didn't work. But again, I squared is equal to -1, right? So this is the same thing as saying 21i over -9 times -1, which is +9. So I have rationalized my denominator. My I has been removed. It is no longer there. However, just like before, even when my denominator was free of its radical, you still have to simplify. So here, 21 and 9 can both be divided by 3. So this fraction can simplify to be 7i over 3, like that. All right. The number 4 right here. So my real number is still 0. Our imaginary piece, it was -2i. So we're going to multiply by the opposite, which is +2i. And if we do one thing to our fraction, we have to do it to the entire piece. So numerator and denominator get multiplied by 2i. Our denominator becomes -4 and then I squared. Our numerator, we're actually going to multiply both of my pieces by 2i. So I'm going to have 2i and then -10i squared. This time, our I squared pops up in 2 different locations. So it happened in my numerator and my denominator. In my numerator, so that's going to give me 2i. -10i squared is saying -10 times -1, so that's +10. Numerator, -4i squared is saying -4 times -1, so that gives me +4. I have freed my denominator of the I, but now I need to simplify. So all my coefficients here can all be divided by 2. When I divide them all by 2, we get I plus 5 over 2. And that is it. All right, let's step it up a notch. All right, so we're going to use our complex conjugates to simplify our complex quotients. So notice here our denominators have more happening to them. So I have a denominator of 2 plus I. I have to multiply by the conjugate, meaning my real number stays the same, but our imaginary is going to change its sign. If I multiply one part of my fraction, I gotta do it to the other. So here we're multiplying top and bottom by 2 minus I. All right. Oops, I'm sorry. My numerator, I'm just going to distribute that 3 to both of these pieces. So this becomes 6 minus 3i. My denominator, here comes that FOIL method again, because now we're multiplying by 2 binomials. So 2 distribute to 2 gives me 4. 2 times -i is -2i. I times 2 is positive 2i. I times -i gives me -i squared. All right, you're like, Miss Douglas, there's a whole bunch of i's still in my denominator. Well, you're not wrong, but look at what can happen here. -2i plus 2i, well, that cancels, doesn't it? That just gives me 0. And then this guy on the end, -i squared, that's -1. So our denominator really simplifies to 4, and the -1 is just +1. So we end up with 6 minus 3i divided by 5. So look at that. I multiplied a conjugate to itself and just got a nice real number out of it. There is no more I in my denominator. All right, let's try number 2. All right, so we have 3 minus 2i divided by 4 minus 3i. So we need to rationalize our denominator. So my real, using my complex conjugate, Our real number is 4, that stays. Our imaginary will now be positive 3i, and I have to do it to both pieces. All right, so this one we're going to have to FOIL both pieces of my fraction. So we will have to FOIL my numerator, and we're going to have to FOIL our denominator. Okay, let's do our numerator first. 3 times 4 gives us 12. 3 times 3i is going to be 9i. Then we have the middle piece, negative 2i times 4 is negative 8i. Negative 2i times 3i is going to give me negative 6i squared. Same thing with our denominator. So 4 times 4 gives me 16. 4 times 3i is positive 12i. Negative 3i times 4 is negative 12i. Negative 3i times 3i gives me negative 9i squared. Okay, let's try to combine like terms. My numerator, all right, we know this piece is saying negative 6 times negative 1. So this is just equal to a positive 6 right here, okay? So our numerator, so 12 plus 6, that gives me what, 18? And then my imaginary piece is here in the middle. 9i minus 8i leaves me with a positive 1i. So I'm just going to say 18 plus I. Our denominator, all right, so again, simplify this last piece. Negative 9i squared is like saying negative 9 times negative 1, which is positive 9. And my middle piece is 12i minus 12i. Well, there it goes again. It's canceling out. So I don't have an I piece in the middle. Instead, we're left with what? 16 plus 9, which gives me 25. And that is our final answer. So again, my conjugates canceled out enough to where I had just one real number left over. All right, let's see if it happens again for number 3. I have a good feeling. So looking at number 3, we have I being divided by negative 2 plus 5i. So we need to multiply both pieces by the complex conjugate of my denominator. My real number stays the same. Our imaginary number changes the sign to be negative 5i. I do it to one piece, I gotta do it to the other. All right, so when I multiply my numerator, my I is going to get distributed to both of these pieces. So I times negative 2 becomes negative 2i. And then I times minus 5i becomes minus 5i squared. Our denominator, here we go. Negative 2 times negative 2 is positive 4. Negative 2 times negative 5i gives me positive 10i. 5i times negative 2 is negative 10i. I see a pattern. Look at those middle pieces. They're already canceling. And then 5i times negative 5i gives me negative 25i squared. Okay. Numerator, combine like terms, but I can simplify this first. So this is really negative 5 times negative 1, which gives me positive 5. So my numerator has a real piece of positive 5 and an imaginary piece that is still negative 2i. Our denominator, I see 10i minus 10i, so they're going to cancel. And then this last piece, negative 25i squared, is negative 25 times negative 1, which is positive 25. 4 plus 25 gives me 29. There we go. There's no simplifying after these because they would have to, all my numbers would have to be divisible by the same thing. Okay, so here 6, 3, and 5 don't get divisible by the same thing. 1, 18, 25 not going to work. Negative 2, 5, and 29 not going to work. So these are as simple as it gets. Okay, there was a pattern here. You're in honors class, so I want to show you the pattern. If you noticed, every single time we got a real number as a result. Okay, there is a pattern to these real numbers. Okay, if we multiply a complex number, so a plus bi, and we multiply it by its conjugate, a minus bi, there is a shortcut that you can use every single time. And this shortcut is going to be a squared plus b squared. Like, what are you talking about? Well, if you look at this example, 2 plus I, my a is technically 2, and my b is technically 1. So 2 squared is 4, 1 squared is 1, 4 plus 1, look at that, we got 5. It's going to happen in the middle too. So we did 4 minus 3i with the conjugate, 4 plus 3i. 4 is my a, 3 is my b, 4 squared is 16, 3 squared is 9, 16 plus 9, 25, there it is. Over here, my a value is 2 or negative 2, because when you square a positive or a negative, we're going to get the same thing. So my a value is negative 2, my b value is 5, negative 2 squared is 4, 5 squared is 25, 4 plus 25 is 29. So this is a little shortcut for you guys if you want to use it. It might save you some room on your papers when it comes to rationalizing your denominator. Okay? So that is complex conjugates. You have a worksheet to work on. There are 20 problems. The very last one, number 21, I did cross that off, so don't do that. Just do the 20. And then you also have a quiz review to work on, and I will open up Zoom here in a little bit. I'll send you an announcement at exactly what time I will open up the Zoom for you guys to ask me any questions about complex conjugates or your quiz review. I'll answer questions about anything, okay? Your quiz in here is going to be on Friday. So, good luck, guys, and let me know if you need me. Thanks.